Cool. Well, good morning. Welcome to Code Camp 2017. I guess this is the first session of the morning, so this is a great way to start learning about cloud functions and start your coding experience. So I'm JeanCarl Bisson. I'm a developer advocate at IBM in San Francisco. So if you come out to any of our events, you'll probably see me hanging out, eating food, talking to people, and most importantly, writing code. Developer advocates build demos for IBM, come out, explain how we've built them, explain how you can also build the sample applications, and most importantly, use those as a foundation to build whatever your dreams are, and whether it be a startup or an enterprise solution, we're here to support you. So if you ever see me on the street, I'm usually wearing an IBM t-shirt. You can recognize me. Come up and say hello. I'm always willing to talk to you, unless I'm on the way to a session. I got to make sure I'm always on time for the session. Here's my email address, jbson@us.ibm.com. I'm also on Twitter at dothewww. I started as a web developer, so I do the www is honoring the web as my ancestry, I guess. So, has anyone back like 2 decades developed a traditional website? All right, we've all lived through that horror. Don't worry, there's better things to come, and so a very traditional website, you used to have to pay for shared hosting. You got some web space, some bandwidth, and maybe a database, etc. And that was great in a shared hosting, but when you got to a point that you were hitting the database too much or overutilizing the resources, you would get an email saying, stop utilizing the resources, or we're going to start charging you. But good news, you can upgrade to a server, and so when you got to a server or a virtual machine, you then had to have experience with command lines and server admin skills. And I'm a developer. I want to write code. I don't really worry about efficiency in my code at first. And so I may hit those limits, and then I sit there with a production website and a threat that it's going to get taken down for overutilizing resources. So it's not a very developer-friendly environment. And then you may have a customer that's in another time zone, and they wake you up at 2 a.m. saying your website's down because your database is overloaded or whatnot. And again, developer, I want to write code during my waking hours, go to sleep, enjoy my sleeping, not get paged in the morning at 3 a.m. saying we're losing money, right? Bad things happen. And then if you do have a way to scale out, how fast is this going to actually scale out? Is it going to be an hour, 2 hours, days? I've actually had a website that was down for more than 24 hours, and that was super stressful as a startup, going, oops, yeah, can you wait till tomorrow and we'll have it back up and running? That as far as credibility for your startup, that's really bad when your client is saying, all right, I can go somewhere else and have better uptime. And then if you do scale this up, you have to scale it down, or you're paying hundreds and hundreds, or maybe thousands, millions, whatever unit that you're paying for it when there is no usage, and you've got to tear down your servers as quickly as possible. So there's a lot of issues with a traditional infrastructure, but that's still okay if you want to be the system admin. But there's newer and better things now. So the services in Bluemix will help you manage some of these things in the traditional website experience. You can have a monitoring system that will monitor memory and resource utilization, scale up the servers or Cloud Foundry applications as needed. and then automatically tear down the resources as needed. But still, that's still traditional websites. So the next thing that came about was microservices. And so you have this monolithic application, and you have to scale that whole chunk up and down as the demand increases and decreases. So microservices, the goal was to separate out components. So you might have certain components of your service needing to be scaled up and down separately than the other parts of it. So you break down the large application into smaller parts that can be scaled. You basically have APIs that the system understands how to call, and then you're not really coupling code base in the code, but rather a abstraction layer that you can basically keep constant, but then switch out the services underneath. And so when you're improving your service or saying, okay, MySQL was great, but now we want to go into a NoSQL database kind of format, you can switch out the underlying service, but keep the API endpoints similar. And then you can scale out the components individually during peak hours or peak usage. So that was kind of microservices, and all right, cool, this is better life as a developer. I don't have to manage servers, and I can scale up pretty quickly. And then Cloud Functions came along, and you might hear Lambda from Amazon, Cloud Functions from IBM Bluemix, Azure Functions, and Google Cloud Functions, or a couple of them. Basically, this is, I guess, abstracting out a smaller component of these services. And so you might have a certain activity like sending emails every evening, sending a reminder to your customer. Rather than have an application running 24/7, well, that 1 hour every evening, you're just running this function or this code and sending out an email, and then that's it. The rest of the 23 hours, you don't want to have this infrastructure running and pay for it. And so Cloud Functions, you can basically run at any point and at any scale you need. There's other uses for Cloud Functions. You can have certain processes. So maybe a customer submits a support ticket, and there's other things down the line that get called, but it's not in the time frame that you get back to the customer and say your support ticket has been processed. It's really after that fact that sometime down that timeline, you can call maybe figure out which customer service agent could be available, assign that ticket to them. You might run a monitoring system or a monitoring cloud function that says, okay, is this service up and running? Get some info, attach it to a ticket. Basically any components that you want to run at any point through the process, you can encapsulate into a cloud function. And the great part is, as a developer, we want stuff for free. We don't want to pay for it. So you only pay for the amount of time and the amount of memory and resource that you utilize during that execution point. And if you're talking about like a half a second, that's pretty reasonable cost for that functionality. So IBM Bluemix, which is our cloud platform, supports Cloud Functions in these languages: Node.js, Swift, Java, PHP, and Python. And if you're a Docker fan, you can actually deploy Docker containers into the environment and run whatever code or whatever program that you need in that Docker container. So which option is the best? It's just like which programming language is the best. It's really up to you on your solution. And if you want to come chat with us, we're available to discuss how your solution may utilize the Cloud Function again, you may have a mix and match where you have infrastructure, you might have a Cloud Foundry application, and you have the functions as well. So some of these questions that you might have is, all right, so my code is tightly integrated and coupled into a larger process. Maybe that's more of a traditional environment. The worst thing as a startup I've done is rewrite my code base for I guess the reason, yeah, it can be more efficient or whatnot. That's a big time waster. So I highly advise that you don't just say, okay, Cloud Functions is the next big thing, and we're going to rewrite all the infrastructure into Cloud Functions and spend 6 months or 3 months, what I don't know the exact time scale on a big application, but it's not a very quick thing. And yeah, it's only going to be a 2-week sprint. Don't worry, we're going to rewrite it all and be done, and it's going to be tested. No, don't go down that path. I've done that. I've seen a startup die that way. So bad things happen when you want to rewrite code. Just keep your existing solution and add these things into it as needed. Does my code need to run all the time? Well, that you're running it all the time, so Cloud Functions are going to be either comparable price, or it depends if it's going to go up or down. If you're not running it all the time, you're going to start saving money immediately by not having it run and not needing to pay for it. So does my code run infrequently? So maybe every night you're doing a batch job. That's when a Cloud Function is going to be very useful in your solution. All right, let me jump into the Bluemix Console. And you'll notice the TJ bot. I'm going to get to that in a moment and show you how that uses the Cloud Functions. But I'm going to just create a very basic Cloud Function and show you what the Bluemix Platform can do. So under the menu here, under Functions, you get access to all these things. And the first is a command line interface. So if you're the hardcore developer, oops. Thank you. Stay until the end, and then you're going to be really excited about the TJ bot. And you're going to...
No idea. Sorry. You're using your phone and do a hotspot. Okay. So yeah, if you have never used the Bluemix on that, please still log on. It's free for you guys, 30 days for free. So now JeanCarl is going to talk about the sections that he's going to show you what kind of service you can get for free, and you can play with it.
Yeah.
But we're going to have an award. You guys can win something by the end of the day. You can take that challenges. Okay. So take a look.
Thank you, Juanita. All right. So this is Bluemix Platform. So on the left side here, you get access to databases, runtimes, finance. So if you're doing blockchain stuff, you can deploy solutions there. Internet of Things. This is an Internet of Things device. I'll show you that in a bit. And then Watson, which is our cognitive AI services. We have sessions today and tomorrow about these topics. Stop by the booth to get those times, or look on the IBM track in the Silicon Valley website. So under the Functions section, you get launched into the Cloud Functions section. And so there's a couple of components here. The Getting Started will show you the command line interface. So if you're a developer and you really like the command line, you can use an OpenWhisk command line interface to create actions, to deploy the APIs and whatnot. We have SDKs that you can interface with the OpenWhisk APIs. So you can call it from maybe a mobile application or basically anywhere that has cloud connectivity. Documentation, you can really learn more about Cloud Functions. And then the last couple of sections, Manage. gives you all the lists of your cloud functions. You can package them up together to organize them, kind of like folders. And then developing, you get access to the IDE. You can monitor your APIs and then expose them monitor your functions being executed and then access or build an API around your functions. So let's just create a simple, let's see, hello coders, because we're all coders. So an action name is just a simple label for you to be able to reference to it. You can have different packages like folders. I have a public package and a TJBot package, and then different runtimes. So you can run Node, PHP, Python, Swift, and then, let's see, click on create. And so if you don't want to use a command line interface, you can use a web IDE. And this is basically a code editor where you can run, this is going to be Node.js. And it returns a JSON response. So when you call your cloud function, you get a JSON response back. And I can invoke this here. And it returns a simple JSON object. But let's make something a little bit more complex. So name equals params, name or guess or coder. And so let's see, plus name. So what this is doing is, so whenever you call your cloud function, you can pass in parameters, and that gets passed into your main function as an object. And so I'm going to either take the name property if it's passed in, or if there is nothing, I'll fall back to coder, and then I just append it to the message. So if I run this again, save and invoke, it says hello coder, but I can also change the input. So name equals, whose name do we want to run? My name. But it's always going to work when it always works with the speaker. So I'll apply the function and invoke it, and you'll see it's changed dynamically. So great, I have this simple, or actually very complicated cloud function I'm going to monetize, and this is going to be so cool. So I'll be able to expose this as a web action. And so you see there's this URL. And if I go over to Postman and post, let's see, the name, JeanCarl. Oops, let's see. Name. What happened here? Well, let's see. No, it's actually a let's see, what did I do wrong? All right, I'll have to come back and see what I did wrong. Headers. All right, early morning. But basically, you get a URL here. It can also do it, name equals JeanCarl. Uh-oh. I guess name equals, Param name coder. Name. Save. Let's see. Which. Firefox. Name coder. Did I get that right? All right, one more time. Name JeanCarl. All right. I think I'm missing one step in between. It might not be saving. Question?
Yeah, in the back end, is it running a Tomcat or is it running a WebSphere? What exactly is when you look at that?
So the question is, what is Cloud Functions based on? It's actually based on the open source Apache OpenWhisk project. So IBM is a huge contributor to open source projects, and we contributed to the OpenWhisk project, and then brought that into the Bluemix platform. So, all right, so let's move on to the TJ bot. Let me get to that question in a moment about authentication. So the TJ bot, you may see this cardboard box and, oh, that's cool, what is it? And a couple of you came this morning and opening up the box and it's like, cool, what's this thing? And it's like fragile, it's a TJ bot. No, so this is a Watson Maker Kit, the first Watson Maker Kit, powered by a Raspberry Pi. And it's kind of a project that you can adopt and learn about the Watson services that you can include into the TJ bot or anything, any device that you want to include Watson into. So it's a Raspberry Pi powered application. It's running either NodeRed or Node.js. There's libraries in both those languages. There's also a Swift playground that you can play with the virtual TJ bot. And then tomorrow during my session, you can also play with the virtual TJ bot simulator in Node.js. So you can get a microphone, a speaker. There's a camera in this one, a LED, and a servo. And then it's got uses 6 Watson services, so it can translate content from one language to another. It can recognize objects and colors using images that you capture via the camera. It can listen to you using the microphone and Watson speech-to-text service, and then it can talk back to you using the Watson text-to-speech service and the speaker. So I have a simple application running, or actually it's not really simple anymore, because I keep adding new things to the NodeRed application. So let me connect over the hotspot. So this is NodeRed. It's a graphical way you can code IoT stuff or even simple applications. It was developed by IBM a couple of years ago, open sourced, and it is actually now part of the JS Foundation. And so I have a very simple application that subscribes to events via the Watson IoT platform. And so when I send a command down to it to say light the LED the color red, it'll understand the command shine and then pass it off to the shine node, where it will either pulse or shine its light. And then it will, it can listen as well. Let's see, listen. So you either start or stop the microphone from listening, and then it passes that audio stream through the Watson speech-to-text service, gets a transcription, and then you can understand what the user has said, maybe through Watson Conversation, which is a chatbot service that we offer. And so if I said turn the light red, it would understand the intent of, oh, turning a light something, and then the entity would be the color red. And so as a developer, I can train Watson with the intents and entities that I want my application, whether it be a TJ bot or other application, it can understand natural language. Question? All right. So let's see. These are all the different commands that I've basically abstracted out into the IoT platform. Oh, shoot. Really? So let's just quickly go back. So NodeRed, graphical interface, these are all the commands that it'll listen to, and it's a switch statement. And when I command it to shine a light, it'll pass it off to the shine node. This one's the shine node. And it will change the LED a certain color. And so what's great about the Watson IoT platform is I've abstracted out a service basically to tell the TJ bot to perform different activities. And so the next step I did was, all right, let's create an API, because everything needs an API in this world. So let's see, back to image. So I created a number of these cloud functions, and these don't run until my API is called, which is going to save me money. Again, I'm cheap on being a developer. I don't want to pay for anything. So let's say I want to shine. This is the code that's going to run in when the API gets called. And so you might say, oh, this is a little bit more complicated, and it is. It's just doing a couple more things. It's returning a promise because some of these activities aren't going to be responding to the platform immediately. So OpenWhisk knows, all right, there's this promise. When it gets returned, then we can return the response back to the platform. So I have this simple payload with a TJBot ID, a color, and a mode parameter that is being passed in. If it's a pulse, I also use a duration, so the light can pulse between half a second to 2 seconds. And then as an API, I want to keep track of every call that is made to the API, since some of these commands get sent down and they don't get resolved immediately. I want to keep track of that status so I can pull the API and say, did the light change? Or it was capturing audio, what was the transcription? So I create a Cloudant document. So Cloudant is our NoSQL database. It just stores JSON into the database, and I can update these documents as new data is published back to the cloud function. And then I have a complete action. So when the TJ bot finally finishes whatever it's being commanded to, it posts extra data. There is a limit to the payload size that your IoT events can publish. So I just expose another cloud function that will be executed at whatever point the data comes in. And then I send an IoT command down to the device with all this information and tell me when you're done, post to this URL. And so that's these cloud functions that I have, and each one has a different command. Where's IoT? So I just include different different commands that are matched in that switch node back in the NodeRed application. So great. So I have all these cloud functions, and I could get that JSON web endpoint and say you call that and pass in whatever commands that and data that you want to send down to the TJ bot. But then I don't really have control over all of you and how many calls you make to those functions. So we have an API offering that you can expose these cloud functions as an API. And so I create an operation, and I can specify what path in my API I want to expose each of these cloud functions in, what method or verb, HTTP verb you want to, whether you want to post the data or you just want to get it or put it, delete it, all the common verbs, and then which action you want to expose. And so you create your definition, and then you can specify whether you want to require an API key. So there was a question on authentication. This is where the API key and the client ID and client secret come in. So I can give each of you an API key, and when we're done with calling the APIs, I can revoke that API key. Or if you happen to post it on GitHub, which is very common, I can always revoke it, reissue you another API key. All right, so I have a Shine, let's see, we'll do Shine, and so this is Postman. You can make API calls using it. Here are some of the parameters that I have been playing around with. Text won't be utilized in the Shine. So pick a primary color that you want besides red. Blue? Blue, IBM Blue. All right, so I'm going to make an API call to the API. It's going to then pass it off to the cloud function, the Shine cloud function, send an IoT command down to it, and then we're going to have TJBot shine its light.
I'm going to go ahead and interrupt a little bit. If whoever's been using Wi-Fi, just go on to conferences. Your SSID is the conferences. When you're logging on, the password is hiring now as one upper letter cases for IBM. So please using hiring now. Thank you.
Cool.
Got it?
It's conference, right?
It's conference.
Cool. So you notice it changed blue, and because I want to test another one and really show it works, it turns green, right? So you can see a very simplistic flow, but it utilized a couple of services in Bluemix. It was the API service that exposed the cloud function. The cloud function called an IoT command via the Watson IoT platform, and then this is subscribing to those events. So really, nothing is running except this is using power, and whenever that API gets called, then that execution time happens. So if I'm interested in how's my API doing, I can go in and monitor and you'll see I made a couple of calls earlier, and then, 5 calls just a minute ago. So I can go in and inspect, and it's actually only about half a second, and you'll see TJBot is making a request back to my event endpoint to say, all right, I completed that activity. So that's about 100 milliseconds. Cool. Any questions on that? So if you're workings of how that worked, just kind of follow from number one and go through, connect the dots. And then CloudInt is keeping track of all those events and storing them, so you can call that call the event endpoint and get the event status back. Cool. So if you're interested in more about the TJ bot, we have a developer journey at developer.ibm.com/code. If you're interested in the API side, we have a couple of journeys, one showing you how you can connect a MySQL database, and I believe it's creating cats, because everyone wants to create cats in a database, showing you the create, update, read, and delete functions. And that's it. Any questions?
So no cameras, camera, for example, like remotely add a camera module to the TJ bot.
Yeah, so this one has a camera, and it's just connected to the Raspberry Pi.
Okay. There's a camera module, there's a Raspberry Pi, and then internally it connects to the Watson service. I will be able to stream a video.
So, recognition demo. You can go on visual recognition demo.mybluemix.net and play around with how the image analysis happens. But I'll just analyze quickly an image of a person, and you can see the classifiers that get returned. There's a red color, and then it will detect faces and try to understand if it's a male, female, and age range. So you're just passing in an image, and it will understand what's in that image.
So I could set that on my desk, run a routine, it would look behind me and say, your boss is speaking up.
So there's an idea that you can analyze, or have TJBot look behind you and back you up if someone like your boss. Yes, but just remember you're sending images up to the cloud every half second, and you want to make sure that you're actually going to be paying Watson for every analysis. So you might want to be smart about that, or use a local process on the Raspberry Pi to detect a change, a significant change, and then classify that image and say, okay, there's a monster. I mean, a nice person, right? I'm sorry, boss. All right. And you had a question?
Yeah, I was just wondering if you offered, like, is there a free tier?
All right, free tier, because I guess most of this I don't want to pay for anything. Yes, we offer free tiers on the Watson services. So sign up for your free account at bluemix.net. The 30-day trial will bump you up on capacity, and so you can really play around with it for the first month. After that, it's going to be those free tiers, and that should be sufficient to prototype things. Again, you can't run your startup off free tiers. Please understand that. Make your customers pay for your service, and then you can pay IBM pennies. We're not charging that much for these services, so it's very reasonable. Question?
So, what similar from AWS and Watson?
What's similar in?
What the clouds or the
Okay, so the question is there's many clouds, and yeah, they're doing similar things. It really depends on what you're trying to accomplish, whether it be cognitive services or infrastructure or database services, many different things. Our benefit is if you're an enterprise company, we offer on-prem solutions as well as in the cloud, and also hybrid approaches. So if you have something specific, feel free to stop by the booth and we can talk more about that. All right, well, I'm out of time, but stop by the booth, play around with the TJ bot. We have a code challenge that you don't want to miss because we're raffling off a TJ bot tomorrow. And again, stop by at 1 o'clock tomorrow for my talk on the TJ bot, where we're really going to dive into the components of the bot. All right, thank you very much.